Hi guys, in this video we're going to be talking about Bernoulli sequences and binomial probability distributions. So really quickly, a Bernoulli sequence, which is sometimes referred to as a Bernoulli trial, has three key features. The first key feature is that there are only two possible outcomes. So for example, you can either win or lose, or you can have a success or not a success. The second is that the probability for each trial must be constant. The third is that each trial has to be independent. So for example, the outcome of past trials should have no impact on the outcome of any future trials. So the formula to calculate a binomial probability is on the screen here in red. So N represents the number of trials, R represents the number of successful trials, P is the probability of success, and Q is the probability of failure. So what that also means is that if Q is the probability of failure, and the total probability has to add up to 1, then we could say that Q is just going to be 1 minus P. So question 1, we've got two people playing chess regularly. They both determine that player A wins 70% of the time. If the two people play 10 games, then we want to calculate the probability that player A wins exactly 5 games. All right, so first things first, let's just write down what we know. So we definitely know that N, the number of trials in this case, is going to be 10 because there's 10 games played. We know that the probability of success for player A, we'll assume, is going to be 0.7, and therefore Q, the probability of failure, is going to be 0.3. So for part A, if we want to find the probability that someone wins at least 5 games, how we would set that up is we could say the probability of X being equal to 5 equals 10 and 5, because 5 represents the number of successful trials we're looking for. Then we're going to have times by 0.7 to the power of 5, and then we're going to have times by 0.3 to the power of 5 again in this case. So these two numbers won't always be 5, it's just coincidentally worked out that they're both 5 in this case. So something that is important here to know, this bracket here where you've got 10 and 5, what that represents 10C5. So once we get to this step, this is just a calculator job. You'd never be expected to do something complicated like that without a calculator. We get 0.1029 if I was rounding to 4 decimal place. So for part B, now we are finding the probability that a player will win at least 2 games. The long way to do this question, if we're finding the probability that this person wins at least 2 games, the long way, which you should not do, would be to go and find the probability of X being equal to 3 plus the probability of X being equal to 4 plus the probability of X being equal to 5, etc. until you get to the probability of X being equal to 10. That's going to be long and tedious. There's a quicker way that we can do this question. So if we're trying to find the probability that this person wins more than 2 games, well, we could say that that's going to be equal to whatever 1 minus the probability of winning 0 games is, minus, again, the probability of winning 1 game. The reason why we can do this is because the total possible outcomes of any probability situation is 1. So using the same process as above, we're going to get the following. So we're going to end up with quite a long equation. Then we can just put all of that into a calculator. And that's going to give us an answer of 0.999856. So we can just round that to 0.9999. So there's almost a 100% chance that player A is going to win at least 2 games. So for part C, we've been asked to find the probability that a player wins either 4, 5, or 6 games. So that would be represented by this situation on the screen here. So we're going to end up with that long equation that's now on the screen. Then when I put all of that into a calculator, I'm going to get 0.3398. So there's approximately a 1 in 3 chance that this person is going to win either 4, 5, or 6 of this total 10 games. So for question 2A, it says that a shop owner knows that 80% of customers pay with card. So automatically, I would be thinking that P is going to be 0.8, which represents paying with card, which therefore means that Q, paying without card, is going to be 0.2. We aren't told any information about the number of trials yet, but for part A, it says that 3 customers in a row pay with card, and the following 3 customers pay without card. Right. The key thing about this question is there's an and in the middle there. That and means that we're going to have to multiply probabilities together. Also, that explains why, for example, 1C here, that explains why we actually added the probabilities, because we had an or here. So or means add, and means multiply. So essentially what we're going to have to do is we're going to have to first find the probability that 3 customers in a row pay with card. We'll do that kind of on its own in a way. Then we're going to find the probability that 3 customers pay without card, also in a row. Then we're going to multiply those two probabilities together. So when we put all of that into a calculator, we're going to get 0.0041 approximately, which if we wanted to change to a percentage, it'd be 0.41%. So there's a 0.41% chance that we're going to get 3 people in a row pay with card, followed by 3 people in a row paying with cash, which kind of makes sense because that'd be a bit of an outlier situation. So what we've been doing so far is we've been going through this algebraically the long way. In the next part of this video, I'm going to show you a shortcut using the TI-Nspire graphics calculator that's going to help you to do all of these types of questions way faster, which is obviously convenient for tech active exams. So question 1 using the TI-Nspire calculator, first thing we're going to do is click on menu. We're going to click on probability. We're going to go to distributions, and then we're going to click on option A here, binomial PDF. We're going to enter the number of trials. In this case, it was 10. We're going to enter the probability of success, which would be 0.7 in this case. And then for question 1A, it wants to know exactly, so what is the probability of winning exactly 5 games? So I'm going to click a 5 in here, and that gives us an answer. So what we could have also done alternatively, instead of always clicking menu, you can always type this in. You just have to remember that this first value here is your number of trials. The second one is your probability. Third one is the number of successful trials that you want. If we wanted to do part B now, this is player A wins at least 2 games. What we can do is we can go menu, we can go probability, we can go to distributions, and instead of PDF, we want to go CDF. So we're going to enter the number of trials, which is 10 again. We're going to enter 0.7, which is the probability of winning or of a success. Then we can just enter our upper and lower bound. So instead of having to do 1 minus the probability of 0 minus the probability of 1, we can just enter our lower bound and upper bound, and it will do all of that for us. Yep, cool. So that's what we got for our answer. And then for question C, we can do a similar approach to what we just did. So I'm going to copy that. And then I'm just going to change the range to being from 4 to 6, which is what we want for option C. As much as it's good to obviously know this calculator trick, it's also just as important, if not more important, to actually understand the algebra, understand the mathematics behind what's actually happening when you enter this into a calculator. That's it for this video, guys. Thank you for watching.